Hi and welcome to ICS Arabia. Glad to be here again with my special guest, Steve Mustard. He's a control system engineer from the UK. He's been in engineering for many years or decades. He's a consultant and an expert, and he's done many roles in the OT space and I'm sure OT cybersecurity. So welcome, Steve.
Hello, yeah, thanks for having me. Looking forward to talking to you today.
Pleasure to have you. And before we dig in, could you tell us about your background and how you started as an engineer and what got you into OT security? And please.
I started work developing real-time embedded systems for defense and space industry, and that experience was very instrumental in helping me understand the importance of equipment in control systems as well. Obviously, the real-time nature of that is very important. So I moved from developing those kind of solutions to working in the SCADA and control system world, mainly in the water industry. Then I started my own business. I did a management buyout of the company I worked for that made the SCADA products, and started my own company doing that. And during that time period, that was around about the time when cybersecurity of control systems became a real thing. Obviously, cybersecurity was a thing for many years, but the focus on control system cybersecurity wasn't really there until probably the early 2000s. And I got involved as a result of some of my customers who were concerned about control system security, and started to get involved more and more in that. Around about that time is also when ISA, the International Society of Automation, started developing their 62443 standard as it is now. So a lot of things were happening then. But over the years, I've got more and more involved in that because it's become a bigger and bigger issue for people. So since I've been here in the US, since 2008, that's been my primary focus. So I've been helping customers in asset-intensive industries, particularly oil and gas and water and wastewater, either understand their risks from a cybersecurity perspective or develop cybersecurity management systems that can help manage that risk and develop training for their people so that they can understand what they need to do in order to manage the risk. So that's been very much the focus of my work for the last 18 or so years now.
Nice. And I noticed that you've been involved with the ISA for many roles and many years. When did you join them, and what did you do? I mean, I saw that you became a president once, and there are titles that I don't get it. Past president, treasurer. Could you tell us, please, Steve?
Sure. I got involved with ISA when I moved here to the US. Someone invited me to an event, and I got involved in that, and I thought this would be a good organization to devote some of my volunteer time to, because it was their vision and mission very much aligned with what I was keen on. And since I've been involved, I've done all kinds of different things with ISA. So I've contributed to their standards development. I'm an instructor in cybersecurity, and I've written 2 books on cybersecurity for ISA. And I work on ISA's events programs around the world, a lot of which involve cybersecurity as well, because it's such an important topic for ISA. And as you said, I was the president of ISA in 2021. And the process for being a president of ISA is that there's an executive board, which is obviously the governing body of the society, and you kind of start as a member of the executive board. Then if you're elected, then you can become treasurer, for instance, so they're obviously overseeing the financial side of the society. And then you can also become president, and to be president, you're actually president in the role technically for 3 years. So you're the incoming president or the president-elect secretary for 1 year, then you're the president, and then you become the past president. And that's all about having this seamless transition and, handing over from one president to the next to give that continuity. So I'm still involved today. So I still do cybersecurity instruction for ISA's cybersecurity expert program that they have. And I still contribute in terms of writing for ISA and contributing to standards. And right now, for instance, I'm working with ISA on a program called ACSSA, which is the Automation and Control Systems Security Assurance Program. So the idea of that is to provide an assurance program for asset owners to verify that their facilities are secure, which involves assessing all different aspects of an asset owner's cybersecurity management system. So that's coming out this year. So I've been involved with that for the last few months, and so there's always something interesting, and it's always moving this cybersecurity issue forward and trying to help the industry be more secure.
Interesting. And how do you teach in ISA? Do you teach them in the campus or online, or how do you do it?
There's a variety of methods. A lot
Yes.
of training these days is virtual. So a
Sure.
lot of training happens online. Students, it's live, instructor led, but it's virtual, and the students can be anywhere in the world. But I also do training at ISA's headquarters in Raleigh, North Carolina, in the US, and often with ISA's events, we do training courses at the event. So in Brussels this year, in June, we had ISA's annual OT Cyber Summit, and we ran 2 ISA cybersecurity training courses, one on the fundamentals of 62443 and the other one on risk management. And I taught the risk management course there. So, and I also sometimes, depending on the asset owner or the company, they actually want to do their training on their own premises and bring their own people together. And we do that quite frequently as well.
So you just mentioned risk management, and last time when I talked to you, you wanted to really talk about it, and because you think it's misunderstood or not maybe applied correctly. Could you tell us, why it's important and why you think risk management is not is misunderstood?
Yeah. Well, the most important aspect of cybersecurity management is understanding the risks. And the reason why I say it's misunderstood is because for a number of reasons. One is that firstly, a lot of people, when they talk about risk assessment or risk management, they're actually talking about vulnerability management. So they're talking about have you assessed whether you have gaps in your technology or your policies and procedures. That's not risk assessment. That's a part of risk assessment, but it's not risk assessment. The most important gap, I think, is that especially in OT, especially where we're talking about cyber physical systems, the importance of risk management is that understanding what the potential consequences are of a cyber incident. And this is where I think a lot of people don't properly understand. So because we talk about cybersecurity, a lot of the discussion focuses around either information security management issues, or it's a misunderstanding of what a consequence is. So what I mean by that is, if I say to you, what is the consequence of a cybersecurity incident? It is not that my engineering workstation has been compromised, or it's not that my PLC has been compromised. That is not the consequence. The consequence is my process is no longer under control, or I am unable to view the status of my process, or I'm unable to shut down my process, or as a result of that, there could be some consequences like a fire, explosion, could be harm to people, it could be harm to the environment, and so on. Those are the consequences. And risk assessment is all about understanding what those consequences are. And we actually already do that in these cyber physical environments, in these asset intensive industries. We already do that kind of risk assessment. They're called process hazard analysis or other terms like that. And process engineers and design engineers look at what things can go wrong, and then they look at what controls they need to put in place to either prevent that thing from happening or to mitigate the consequences when it does happen. When we talk about cybersecurity, the problem is that a lot of people get wrapped around, as I said, the technology part. So they think about, how do I protect the technology, the PLCs and the workstations and the routers and the switches, and that's important, but that's compromising those is not the consequence. That's just an incident that causes the actual end result. And as a result of not understanding it, a lot of organizations don't put the right controls in place. And an example being that the most important controls for any asset intensive industry, in fact, even not just in OT but in IT, the most important controls you should have in place are all to do with mitigating the consequences. So there are things like incident response, associated with that backup and recovery procedures, and in the asset intensive industries, things like mechanical fail safes and procedures to manage an incident when it happens. And what I see in all of the work that I've done, and I go to many different sectors, I go to many different facilities and many different organizations, large and small, and the consistent thing I see is that those controls are either not in place at all, or they're in place but they're not properly implemented, because we're focusing so much on cyber security controls, I'll call them, which are things like access control, physical and electronic, antivirus, anti-malware, patching, and things like that. Now, I'm not saying that those things are not important, but if you don't have the mitigation controls important that in place that I mentioned, then those other controls are not going to help you when you have an incident. So let me give you an example.
Yep.
The most likely cause of a cybersecurity incident, IT or OT, is an authorized user. So it's either an authorized user who is non-malicious or an authorized user who's malicious, an insider. So the thing is that all of the cybersecurity controls which we commonly talk about, access control, network monitoring, antivirus, patching, all those kind of things, none of those are going to prevent an authorized user from a non-malicious incident or a malicious incident. So you're still going to have the incident. And if you don't have the mitigation controls in place, that when the incident happens, consequences become severe, then that's where the problem lies. So that's my point. Now, risk assessment, that is how you identify what the risks are, and then that is how you understand what it is you need to do. And lastly, I'll just say that obviously the ISA IEC 62443 series of standards is all about risk assessment. So the entire standard is based on the idea that you do a risk assessment, and the requirements that come out of the process are derived from doing a risk assessment. And that's completely different from all other cybersecurity guidance that's out there. All of the cybersecurity guidance is based on, here are some things that you should do, and you don't have an option as to whether you do them or not. You're just supposed to do them. They're basically fixed set of requirements, and that's okay for some people. That's a way of dealing with it. But how do you look at, for instance, one facility and another facility, and they have different risk profiles for the asset owner? They are different complexities. They have different types of equipment. How can you universally apply the same controls? Well, you can't. But if you do a risk-based approach, like 62443 specifies, then you will take account of those different risk profiles and those different equipments and those different requirements that you have naturally in the process. So that's why risk assessment is so important, but it's also why it's the biggest single gap, I think, that is out there.
So, based on your experience and your consultation, is this the common mistake that organizations have when they call you as a consultant, or why do they normally? What are the common problems that you saw?
So the most common problems are that, firstly, the organization hasn't done a risk assessment. Now, and they may ask me to review something, and then my first question is, where is your risk assessment, and how did you derive this architecture? How did you derive this solution? Where did it come from? And they can't answer that. So that's problematic, because if you're going to look at that, you need to look at it on a foundational basis, on a basis of what is the risk. And if you don't have that risk assessment, it's very hard to say whether something is secure or not. Right, that's the first thing. The second thing is, even if the organization says, well, yeah, I understand what you're saying, we need to do a risk assessment, let's do a risk assessment, we get stuck in a few things. So one common thing is what I mentioned earlier, which is my recommendation, and in fact the 62443 guidance, is your risk assessment process is based on your organization's risk assessment methodology. And this is a really important thing that organizations need to do. Cybersecurity should not be treated as its own discipline, its own set of risks. Cybersecurity incidents are just contributing factors to incidents in your organization, just like safety is, and just like equipment failure is, and so on. So if your organization is going to say, well, we've come up with our own cybersecurity process, our own cybersecurity risk assessment process, then I'm going to say that that's not going to work. And one of the reasons it's not going to work is because what ultimately you need to do is your organization, your personnel need to understand that cybersecurity is just one more reason why you can have an incident. It is not a separate thing that happens outside of everything else. It's just another thing that happens in your organization. And if they understand that, then they will manage that appropriately. If they don't understand that, if they think cybersecurity is separate, what will happen is they'll say, someone else will take care of the cybersecurity problem, my IT department, for instance. And then they'll dismiss it. They'll completely forget it. They'll say, it's not my problem. That's someone else's problem. What we needed to do is cybersecurity needs to be everybody's problem, just like safety is. And so it needs to be completely embedded in the process. So one of the common problems I see when I talk about risk assessment is we get that risk matrix out that the organization has, and it has consequences based on safety, environmental, production, reputation, maybe financial. And sometimes organizations say, oh, well, we need a IT one or a cybersecurity one. And it's I have to say, well, no, that's not the point. The consequences are not my server was compromised or my workstation was compromised. That's not a consequence. That's an incident. The consequence is what happens as a result of that workstation being compromised? What happens as a result of that server being compromised? And what is the impact on the physical world? And if you understand that, then you can properly understand how cybersecurity can affect you, and then you can manage it properly. So that's the biggest problem. And then I guess the last problem is again is joining that all up, right? So the idea of doing a risk assessment is not just a checkbox exercise. It's not supposed to be, let's do this exercise, let's do a workshop, we'll document the risks and then file them away and forget about them. The whole point of doing a risk assessment is everything else derives from that. So, for instance, if you talk about incident response, how can you do an incident response plan if you haven't done a risk assessment? Because what scenarios have you identified in the incident response plan? Where did those scenarios come from? And if you don't do the risk assessment, you won't properly identify the scenarios. And again, if you identify scenarios as my workstation is compromised, that's not going to address the actual risk. So if you're in a production facility, for instance, an offshore oil and gas platform, the offshore installation manager is not worried about whether a server gets compromised. They are worried about whether they're going to have a loss of containment or a fire or an explosion, but they're not worried about whether a server gets compromised. So telling them a server gets compromised is not going to make them concerned about that risk. But if you tell them that you can have a loss of containment as a result of a server being compromised, then they'll listen to you and then they'll take it seriously. So that's really the big reasons, or the big gaps or problems that I see when I do these work.
Cool. And I think this is what most of the industry talk about when they say that the C-level or the C-suite, they don't understand the security people. So what you just said, that's the way to convince the CEO or managers and to spend something on the controls.
I think so. Yeah, I think your point is correct. That the problem is that if the C-suite doesn't understand cybersecurity, the consequences of a cybersecurity incident, then their response to managing those incidents is going to be different. And what we see is, I mean, we do see organizations spending a lot of money on cybersecurity, right? We see people buying technology all the time. Spending, I don't know what the current number is, but it's in the hundreds of billions of dollars a year that people spend on cybersecurity, right? And most of that, as far as I know, goes into products and services, technical controls. But if the C-suite understood the real consequences and understood the real risk that they had as a result of a cybersecurity incident, they would invest that money differently, I think, and they would invest it in ways that they might actually spend less money, in fact, because some controls can be more effective than others. So going back to my point about mitigation controls, in some cases, those mitigation controls are relatively, and I say relatively, low cost to implement, and actually, in many cases, already exist. So mechanical fail-safes and manual procedures, for instance, doing backups on a regular basis and having a good incident response plan. If you had all of those things in place, even if you had an incident, that would mean you could manage that incident such that it would not create severe consequences for you. The mechanical fail-safes would operate, the manual procedures would kick in, the backups would be in place, and things could be restored quickly without having to pay ransoms and such like. And sure, you'd have some outage, but instead of having, for instance, in the Colonial Pipeline case, instead of having a 7-day outage or whatever it was, they might only have a 4-hour outage, for instance. Now imagine what the difference that would have made to Colonial Pipeline in terms of their operations and the cost of operations and their insurance costs and also their reputation as a result of having that incident. So it just goes to show that, again, all the other controls were not going to stop probably having, well, maybe in the case of Colonial Pipeline, maybe it could have helped to some degree, but again, if you'd had a slightly different scenario with a malicious insider who had the username and password for the server, then it's not going to solve your problem, right? So, but having those mitigations is critical. But so yeah, so understanding if the C-suite understands that I'm currently, now that I've got these risks, and we've got these potential for these process incidents and these safety incidents and so on, and I know those risks and I understand that those risks are being managed. If I then say part of that is I need to make sure cybersecurity is managed because we might have these things happen, then they'll treat it differently. If you say to them, we need to have cybersecurity because we're worried our servers are going to get compromised, they're going to treat it differently. So
yeah, totally agree. So this brings us to the question: who does the risk assessment? I mean, they say sometimes some organizations with limited budget and expertise, can they do that? I mean, if they don't have really technical security people.
Well, it's a great question because the most effective risk assessments are the ones that are done with multidisciplinary groups. So you need to have, from the asset owner's point of view, you need to have all the right people represented. You need to have people from the process side, people from the engineering side, people from the operations side, maybe even people from the finance side, but certainly people from the safety side, um, and and those people all have a different perspective. That's why it's
Yeah.
important to have them there. So when you're talking about risk assessment, you need to have all the right people in the room at the same time, because then you have these challenging debates about what is serious, what is not serious. When you talk, so for instance, if you say to an operations person, this incident can happen, this would mean production downtime, how long is acceptable? The operations person is going to say 0. It has to be 0. and then you talk to the technical people and you say, well, it can't be 0. What's realistic? And then you can go back and forth and talk about what is a realistic downtime and how you're going to be able to respond. Because that, again, that's why risk assessment is so important, because how are you going to say what the response time is and how can you meet that response time if you don't know what the expectations are from the operations people in terms of their response, right? So all of it comes from that. So the question you asked though as well is, how can they do it? Now, they're probably not the right people to facilitate the risk assessment process. And the reason is they all have their own vested interests. They all have their own biases because of what they do. And so if any one of those groups that I mentioned facilitates it, you're going to get a bias towards their particular thing. So it's going to be too heavy on safety. It's going to be too heavy on production. It's going to be too heavy on process or whatever it might be. So what you do need is you need someone independent who can facilitate it. And obviously, one of the key requirements for that is to have someone who knows how to do risk assessment and can facilitate things. So that's it sounds obvious, but I've seen occasions where people who facilitate these don't have those skills. So what I mean by facilitating is you have to be able to engage all of these people proactively to make sure you discuss these things. Because again, this is not a checkbox exercise. This is not just saying we've done a risk assessment, these people were in the room, it was on this date, sign, and then we can forget about it. This is a thing about what does everybody think are the consequences, and what does everybody think the severity of those consequences are, and what does everybody think we should do about that, and then come to a conclusion on that, which everybody who's there, who represent their different stakeholder group, agrees with. Obviously, like anything, risk assessment changes over time, and like anything, you're going to have new issues, you're going to have different risks, different threats, you're going to have different vulnerabilities, and so on. So you have to review it constantly, but the same thing applies. You've still got to have the right people, and you've got to have them to discuss it. And if you don't do that, it's no use whatsoever unless you get the right people involved.
Okay. And what's the role of cybersecurity guy? I mean, if he just tell them that there is a worm or malware or ransomware attack or from using threat intelligence, how can he? I mean, can these people understand what's the impact would be if they don't know how the cyber attacks works?
Right. Well, good. Yeah. So again, that's why you need to have all the right people, because yes, in that case, like the safety person, the process person, even the engineer may not appreciate what the threats are, may not appreciate what the vulnerabilities are. So therefore may not appreciate what the potential scenario might be that can cause these incidents. So that's where the cybersecurity expertise comes in, is saying, well, looking at the architecture the way it is now, these are the kind of things that could happen. And this is where it's interesting, because like I said, the cybersecurity person typically, even if they've got an OT background, doesn't know what the actual consequences are as a result of that incident happening, right? So they can tell you that your workstation, which doesn't have multi-factor authentication, could get compromised because there's only a single factor. They can tell you that. Or they can tell you that unless you patch it on a regular basis, you could have an issue with something, somebody compromising it like that.
Yeah.
What they can't say is, as a result, this is how serious that issue is. That's where the process people and the engineers and others and the safety people come in, because they say, well, yeah, if that workstation is compromised, what that means is that we're going to have this incident. So if we take it to, for instance, the Trisis incident, right? So if you look at that as a good case for this, what we're talking about here, if I could say to you that because you don't turn the key in the switch to run mode on your safety controller, that if someone was to get into your safety workstation, they could download either a different program, or they could reprogram, or they could inhibit controls and in their safety controller, right?
Yeah.
So I can tell you that, but what I can't tell you is, well, what would happen as a result? Now, for the process guy would say, well, if you were able to modify the safety controller program in some way, these things could happen. So you've got to join the whole thing up. You've got to join up the cybersecurity things that can happen with the process things. And then if you do that, I think everybody in the room begins to understand now. So we're not just talking about this academic thing that, yeah, sure, the workstation could be compromised and someone could get into it, but we're now actually talking about someone changing safety controls, and that can have serious consequences. Now, going back to that Trisis incident, if we had that discussion, the top recommendation from me would be the procedure for managing that controller absolutely has to be turn the key to program, change the program, turn the key back, take the key out, and put it away. And I know the answer is we don't want to do that because it's inconvenient. It's a long way away, and I have to sit at the workstation, do this, then I have to go and walk all that way, turn the key, then I have to walk all the way back to the workstation, then I have to do my work, then I have to walk all the way back and turn the key again. And I just say, well, okay, so in that case, you're basically saying if the workstation is compromised, the additional control, the additional protection you have in place to stop the controller being modified is not effective. So if I talk to the operations people that you can have a process outage, a production outage as a result, if I talk to the financial people and say how much that's going to cost, if I talk to the safety people and say this could cause a loss of containment or a fire or explosion, they're not going to say we don't want to do it. They're going to say, yeah, absolutely, you have to turn the key. And there's so many examples in safety where it's like that. You know how long it takes to get a permit to do a piece of work offshore?
Yeah.
It can be hours. It can be days before you can actually do the work. And that's to protect people and make people safe. So that attitude should be the same for cybersecurity. I don't care if it takes you an extra 20 minutes to walk all the way and turn the key, and an extra 20 minutes to walk back, and an extra 20 minutes to walk back again and turn the key again and come back again, because that makes you safe. And understanding it is really end to end is the most important thing, because if you only understand this little part of it, you don't understand the full picture.
Yeah. Okay. So, as an instructor, can you is risk management could it be taught? I mean, and who should learn it?
Yes, it can. It can be taught, and in fact, one of the ISA courses, IC33, is actually about risk assessing IACS, Industrial Automation and Control Systems, and it's based on ISA IC 62443-3-2, which is the risk assessment process. And so that course it's a 3-day course normally, including practical work, and the whole idea is to take people through how to do risk assessment in an OT environment based on the standard. Now, I would say if asset owners or organizations, if their people don't do that course, then they need to have some other way of learning how to do risk assessment, right? Because again, at the moment, it's not working. Whatever we're doing is not working. I'm teaching some people, and those people are learning it, and they're taking it forward, and that's good. But if I go out and talk to anybody else, I can read posts on LinkedIn from people who are experts in OT cybersecurity, and I can tell you they don't understand risk assessment either. So that is concerning to me, because that is the most important thing. And if we don't understand the most important thing, we're going to struggle to secure things properly. So, and that's why we have incidents. That's why we have things like Colonial Pipeline. I will refer to them again because it's a great example of, no doubt about it, I don't know the details, but if you're out of production for 7 days because you get ransomware on a billing system, you don't have the right procedures and controls in place. So, and you haven't done the right risk assessment. Because if you had done the right risk assessment and you had put the right controls in place, you wouldn't have been out of operation for 7 days. So, fortunately, I mean, touching wood, we haven't seen so many high-profile incidents like that recently. Maybe things are getting better, and it depends who you talk to. I've talked to many people, and they think my pessimism is misfounded, and they say, "Well, I see great progress, and I see people doing better," and I agree. People are doing better. People are doing better than 20 years ago when we started on this journey, but they're not doing as well as they could do. And as I said, the biggest problem is not so much the asset owners themselves, it's the people who are doing the work who are also misinformed. So that's the biggest concern. Is you've got consultants, you've got product suppliers, you've got system integrators and maintenance providers, and sadly a lot of those don't understand this issue properly either. So if they don't understand the issue, it's no surprise that the asset owner is not going to understand the issue, because that's not their job. So these discussions are great because it helps share that knowledge and these opinions, and the training is good, and blog posts and webinars and presentations are good because it hopefully will get the message out that this is the important thing. Now, on the positive side, I would say there are some examples where I do see more people talking about risk assessment and consequences, so that's good. But for example, there's the Idaho National Labs in the US. They've developed a methodology called, I think, consequence-based cyber-informed engineering, right?
Oh yeah.
CCE. Now, that's both good and bad to me. The good thing is they understand that consequence is where the issue is. The bad thing is, back to what I said way back, which is it's a cybersecurity oriented process. And I don't like that. I don't like having cybersecurity as its own thing, which has its own process. I want people to embed cybersecurity into everything they do, including their risk assessment, including their operations and everything. I don't want to have cybersecurity as this special thing, which has its own special process, which comes with its own special results. I want it to be cybersecurity is just another thing you have to manage like everything else in your facility, and we need to manage it. And if you do it that way, you don't have to have all these special processes. Not only that, but you actually probably integrate it better as a result.
I mean, if somebody hears you now, could he say this? What you just said is complex or simple? I mean, is what you're saying risk management? Should we simplify it or make it?
Yeah, I think you're right. I think that is probably correct. Is the short answer is we've made it too complicated. What's happened is that people who do cybersecurity from an information management point of view have come into an operational technology environment and said, this is how we do information security management. It is its own discipline because it has to be, because it's separate from everything else. And those other things don't include that. But in the OT world, it's not like that. And we all talk about this. We say OT is not like IT, but we often don't grasp one or two of these important things, which is that yeah, the people on the ground who manage operational facilities understand risk. They understand the consequences that they're potentially dealing with. They already understand all of that. So all we need to tell them is cybersecurity is another thing. You don't need to know everything about cybersecurity. We have people who know that part, but you need to know cybersecurity is a thing you need to worry about, and then they will worry about it, and then they will work with the other people. You know, we've had like many years of discussions about should it be an OT or engineering function? Should it be an IT function? Should you have a hybrid team and all that kind of stuff? And again, that's kind of complicating it because it doesn't need to be a special team of people. It needs to be a responsibility that's distributed amongst the people who are already there, so that everybody does their part appropriately to what they do. So the IT people manage this part of it, like for instance, maybe external routers and firewall configurations and stuff. People in the operation facilities maybe manage the backups of the machines that are there because they're proximate to those, and so on and so on. So everybody does their appropriate part, and then it all comes together. Instead of saying, yeah, we're going to have these silos and we're going to create this team and they do this and it has the right people and blah, blah, blah. That also is probably not going to work because, again, you don't want to have the silo. You want to integrate it seamlessly into everything you do.
Yep, I totally agree. And this is why I do podcasts with you, like people like you, so people get the right picture, especially from your long experience. So, are your books? What are your books about? Are they available for everybody, or just for the students, the ISA students?
The first book I wrote was actually a study guide for a certification called Certified Mission Critical Professional. And that certification was developed in the US intentionally for entry-level people. So the people who take a 2-year degree at a community college in the US in some kind of engineering or operational activity, and then they're joining in asset-intensive industry, and they need a quick overview of all the things that are important from operational point of view: risk management, physical safety, security, operations, and so on.
Nice.
But not necessarily super intensive, but certainly an overview of everything. And so that certification is about that. And I wrote a book which kind of, as I say, is kind of like a study guide. So you can take an exam and you can become a certified mission critical professional. So I did that. And then after I did that, I thought I really want to write a book about industrial cybersecurity because of all of my experience and seeing all of these things that I don't agree with or I don't like the way it's done. I wanted to put my thoughts down as to how things should be done. And I referenced 62443 extensively throughout that. But I talked about every aspect of project and operation. So talking about risk assessment, talk about design, talk about maintenance and incident response, and every kind of aspect in there. So that book, those two books are both ISA books. So you can buy them from the ISA bookshop, and if you're an ISA member, you get a discount. And they're also available on Amazon as well. ISA sells them through Amazon, and they're available in physical and electronic version, right? And then I was asked to write a book by the Water Environment Federation. So I work with their safety and security group, and similar to ISA, they're looking specifically at the US water industry, and they asked me to write a book on cybersecurity for the water and wastewater industry. So I recently did that book. So that's similar to the cybersecurity book, but focused very specifically on the issues that are concerning the water industry, and especially the US water industry that has some unique aspects. And I've also written, contributed to other books in digital twin and other things, but cybersecurity wise, those are the three ones. And then I'm writing another book right now with Bob Radwanowski,
Okay.
A lot of people would know Bob Radvanovsky. He's very instrumental in critical infrastructure security, has been for many years. Infracritical, cybersec, all of those kind of things are things that Bob has either created or co-created, and he's very important voice in this. And I talked to him a lot about this risk assessment, and we decided that we wanted to write a book focused entirely on risk assessment for the reasons we've been talking about for the last hour or so. Is this is a big problem still, as far as I'm concerned, and we need to get these thoughts down on paper. So that book is going to be about the misunderstandings about risk, and then how to do risk, what's good, what's bad, why vulnerability assessments are not risk assessments, and how you should not rely on checklists and things like that. So hopefully that book will be interesting as well and move the discussion forward. Certainly that's my intention. Is anybody listening to this who disagrees with me, let's talk about it, because I've been doing this for a long time. This is what I think. If you disagree, then let's see what you think is not correct, and we can work it out.
Yeah. Good luck with your book. Looking forward to read it. So about the standard, the exams and the certifications, who do you recommend to study it? I mean, the people coming from IT background, or engineers, or what's your experience on that? Or should it be beginner or intermediate level?
Well, the ISA training is oriented around understanding the 62443 series of standards, and it starts with an overview, an introduction to it, and then it gets into risk assessment, then it talks about design and development, then it talks about maintenance. So it covers the entire life cycle. Now, anybody can take those courses. So you could be coming from an IT background, and maybe you're not an OT expert, but you will learn it during the course. Or you could be an OT expert and you don't know cybersecurity. Again, you can learn it. Anybody can kind of come into it, and hopefully at the end of those courses, you would be equally knowledgeable, if you like, about how to implement a 62443 based cybersecurity management system based on risk, and then you could manage the risk accordingly. So you can take exams, and you can have a certificate. So you can take an exam for each one, and then if you do all four and you pass all four exams, then you can call yourself a 62443 expert. Of course, you don't have to take the exam, and you don't have to take the courses. But if you don't do that, I'm afraid that I don't know that you're going to necessarily understand fully the standard, what it means, and what it really talks about. And the reason I say that is because, again, over many years, I've worked with lots of people who talk about 62443, and they talk about it as if they know it, and then they will say something, and I will know immediately that they have never opened a page of 62443 because they've said something which is not in there, or it's incorrect. And there's so many examples of that, and it still goes on today. I've seen vendors advertise products that they say are compliant with 62443, and then when I ask the vendor some questions, and they can't answer them, and so that's also concerning as well. So but the book that I mentioned, Industrial Cybersecurity Case Studies and Best Practices, the ISA one, that's a good introduction to 62443 in terms of, if you didn't know it at all, or you were an IT person who doesn't know OT, or you're an OT person who doesn't know cybersecurity. That book is a good way to learn about it before you maybe do the courses as well. So you could glean a lot from that.
So can someone teach himself 62443 without spending on the course, because it's a bit costly? Can somebody do that? Buy a book or something? Is there a way?
You can learn it. I mean, as a member of ISA, you get access to pretty much all of the 62443 standards to read, right? So you can read them. The problem is, standards are not made to be thumbed through and read, right? They're very definitive type of documents that contain normative language and informative language, and they're written in a certain way intentionally. So they're not. It's hard, and if without some guidance, it's hard to know like where to start, what to do. So you could learn it probably, but I don't know if it would be very effective. And as I said, there's a risk that you
Yeah.
don't read the standards or you listen to someone who tells you something and that information is incorrect, and then you go down the wrong direction. So I agree, it costs money to do it, but I mean, if you're going to be doing this as a profession, if you're going to be doing this long term, I've got to say it's worth the investment, because this job is not a thing that you just do. The consequences of getting it wrong can be severe, and it's not something you should just do just because it sounds interesting and you maybe know a little bit. You should know what you're talking about, just like people who do functional safety. That's why you have certified functional safety people, is because it's a subject that you can't just guess and you can't just learn yourself. You have to demonstrate that you understand functional safety, and it should be the same for cybersecurity, really.
So this should be, I mean, who should study this? I mean, the guy who's doing GRC and assessment, or the people, or the technical people like pen testers, threat intelligence people, or yeah, who should learn, get this yourself? Yeah.
Well, I think everybody should know something.
Yeah.
Not everybody needs to know everything. Certain people do, but there are lots of people who only need to have some kind of high level introduction or an overview. And the first course in the 62443 series is probably enough for most people. That's a 2-day course, and that would be sufficient for most people. And I think most people should do that, because, again, remember what we said is it's not about threat and it's not about vulnerability. It is, but ultimately it's about the entire thing, from threat, vulnerability, exploit, and consequence, right? So that's what you get from learning the OT side of it, is you understand the entire chain, and everybody should know that. Now, do they need to know how to do the risk assessment? Do they need to know how to do design and development? Not everybody. So
Okay. So I want to talk about a topic. Maybe it's related. I've been in the UK for many years, and I studied there. Like I told you, I was in Liverpool. So, based on your experience, what's the difference between USA and UK in terms of the OT security awareness, culture? Are they similar in the term that they do OT security? I mean, in summary.
I think the big difference is this difference between understanding risk and sort of prescriptive requirements. So the US, my experience is they're very much base security typically on prescriptive requirements. NERC SIP is a US energy regulation, and it's a whole list of regulatory requirements that are prescriptive, and that's not unusual. And there's a lot of regulatory agencies that regulate things, and their regulation is very typically prescriptive. In the UK is very much risk based. So the health and safety executive says you have to do a safety case, you have to demonstrate that you're managing risk as low as reasonably practicable, and you can effectively do that however you like, as long as you are demonstrating to the satisfaction of the health and safety executive that you're doing it properly. So that gives you more flexibility. And if you look at EU regulations, even though the UK is not in EU anymore, it still kind of follows most of those regulations, and NIS, NIS2, and then the CRA that's coming along for products. All of those are risk-based as well. So they don't say, here are the things you have to do. They say you should understand your risk and you should manage your risk. Now, that's where I think the biggest difference is. So when they come to cybersecurity, I think awareness of cybersecurity, OT cybersecurity, is pretty high now in both parts of the world. And actually, awareness of 62443 is remarkably high as well. So when I went to Brussels, I would actually say a lot of people in Europe know 63443 better than a lot of people in the US, even though it originated in the US. And again, I think it's because they've read it, so they actually do know what they're talking about. And that's another marked difference I've seen.
Nice. So before I end this episode, something caught my attention. Your experience as a freeman in the Worshipful Company of Engineers.
Yeah.
It sounds very British, like
it's very British.
British, yeah, British heritage.
Yeah, that's right.
Yeah.
So that's a recent thing. So yeah, the Worshipful Company of Engineers is one of many livery companies that exist in the UK, and they're all based in actually the City of London. So it's a long-standing tradition of basically craftsmen and specialists in their discipline, creating guilds to kind of support their profession. And engineering is one of those worshipful companies. And like all of the organizations I work with, they're kind of volunteer-led organizations that the idea is to promote engineering in this case, or to support new people in engineering and, you know, give scholarships and to help mentor people and bring the next generation of people along. So I joined that recently. So to be a member, to be a freeman, as it's called, which is a basic member, you have to be a member of a UK Chartered Engineering Institution. I'm a member of the Institution of Engineering and Technology. And then there's another level, which, as a result of being a freeman, you actually get the opportunity to get the freedom of the City of London. And the freedom of the City of London means that it's a very old tradition. It doesn't really mean anything in reality today. It's a nice honor to have, but one of the funny things that you technically are allowed to do is drive sheep over London Bridge as a result of being
I'm aware of this.
and then once you have freedom of the City of London, and if you're a fellow of a UK professional engineering institution, you can become a liveryman. So you actually get clothed. So you get this ceremony where you get clothed, as it's called, and then you get the livery of the company, and then you become a liveryman. So I'll be doing that in November this year.
Oh, nice. Yeah, that's why I laughed when you mentioned the bridge, because I was driving there and I didn't know. I was enjoying the scene. I was driving in my car. I drove from the north. Then after a week or two, I got a fine in the mailbox. It was a high fine, you know, like, I don't know, 100 pounds or something back then, or more. Why? You know?
Well, there you go. So just join the Worshipful Company of Engineers, and then you can pay the fine.
Okay. Yeah, I will never forget this. So it's been really a pleasure and to have you, really, Steve. And
thank you. Great to meet you. Thank you for your time.
Likewise, thank you for joining me. I really learned a lot from you, and I hope the audience too. And how can the people find you?
You can find me on LinkedIn, and hopefully you can share my contact details and maybe the links to the books as well. And then please contact me. I'm happy to discuss with anybody. I
will share the books for sure.
Thank you.
And good luck with your book, and thank you for again for joining ICIS Arabia podcast. Thank you, guys, and take care.
Thank you.